So students, starting from the new topic, that is application of electrolysis. So today we will go through this topic, that where electrolysis is used. So first one is electroplating with metals. What is electroplating? Let's see the definition. It is a process in which a thin film of a metal like gold, silver, nickel, chromium, etc. gets deposited on another metallic article with the help of electricity. So this is the definition of electroplating, that you are depositing a thin layer of these metals which are precious, which do not get rusted, which have their own use for shinier things and for making them expensive, for not getting them rusted, and these metals are deposited. But first of all, let's see one example where I am coating nickel on iron. Okay, so you just go through the example, go through the video where you will see that how nickel is being deposited on a iron spoon, and then after we will discuss this. So now we will see the electroplating of nickel on iron. So for this we will take one iron spoon like this. The whole spoon is made up of iron atoms. You can see here iron atoms. Then we will take nickel, because this nickel has to be electroplated on this iron spoon. So nickel bar is made up of nickel atoms. When we add power supply, the terminal which is connected, the electrode which is connected to positive terminal will become anode, and which is connected to the negative terminal is known as cathode. So this becomes cathode. Iron spoon has to be made cathode. Okay, and then we have taken electrolyte here. This electrolyte is a solution which consists of nickel as well as sulfate ions. So what is the name of the electrolyte? The name of the electrolyte is nickel sulfate. So we have taken nickel sulfate, but because it is in solution form, water molecules are also present. But remember that now I am removing these water molecules so that you understand better. But remember that they are already present in the solution. So nickel electrode is anode because it is connected to positive terminal, and iron spoon is cathode, which is negative terminal. So they are very important things you have to understand. The object that is being plated must be cathode. Always remember, जिसको आपको इलेक्ट्रोप्लेट करना है, जिस पे प्लेटिंग करनी है, उसको आपको कैथोड बनाना है और उसको नेगेटिव टर्मिनल से कनेक्ट करना है. दूसरा इम्पॉर्टेंट पॉइंट, यहाँ पे जो आपके आयंस हैं, ऑल द आयंस विच आर प्रेजेंट हियर, सो द कैटायन ऑलवेज मस्ट बी of the metal which has to be electroplated. Now here in this you can see nickel is there, and nickel ion is the cation which we want to electroplate here. On this iron spoon I want to put this nickel coating. So cation of the metal we want to plate on the object must be present in the solution. So electrolyte will always be of it will be the solution of the metal which we want to electroplate. So what is the electrolyte here? Nickel sulfate aqueous, because water is also there. Okay, and another thing is that the anode should be made of the metal we want to plate on the object. We are making anode as nickel because I want to electroplate this iron spoon with nickel. So nickel will be made anode, और जिस पे electroplating करनी है, that will be made as cathode. So when the charge is put on, nickel is positively charged, this anode is positively charged, and this is negatively charged. So the ions move towards the negative, positive ions move towards the positive, negative ion moves. So oxidation happens at anode and reduction happens at cathode. Remember, I have given you a mnemonic: red cat and an ox. What is oxidation? It is oil. You have to remember it with oil. Oil means loss of electrons. Oxidation is loss. So here loss of electron will happen, and on the cathode gain of electron. Reduction is gain of electron. So here gain of electron will happen. These ions, nickel ions, which are positively charged will go to the cathode and they will gain electron and will become nickel metals. Okay, and here this nickel will lose electron and will become nickel ion. We'll see. So we'll see that on the cathode this is the reaction at the cathode and this is the reaction at the anode. Now here you have to remember that this is just opposite. At the anode the reaction which is there is nickel metal, which is here. Nickel atom is losing electrons and becoming nickel ion. So these are converted into nickel ions, and here these nickel ions, when they come at cathode, they gain electron and become nickel atom. So Ni2 plus will become Ni. Here Ni will become Ni2 plus. So opposite reaction is happening at the cathode and the anode. Let's see what is happening only on the cathode. Electrons are coming here. Each nickel ion is gaining how many electrons? 2 electrons. So one more electron will come here and it will gain 2 electron, and now this Ni2 plus will become Ni. Okay. So this Ni2 plus will become Ni. As you can see here, it has become Ni. Similarly, all the nickel atoms all the nickel ions which are there in the solution, they will come to cathode, gain 2 electrons and will become nickel atom metal. Okay, and they will deposit on this spoon. So the nickel atoms that are forming will keep on forming and gradually coat the surface of the spoon, forming a thin plate of nickel on the spoon. And you must be thinking, but what about they are getting used up, so their concentration will deplete or finish? But it will not happen because you have taken nickel anode. So Ni2 plus ions will be given by the anode. Let's see what is happening at anode. Here this nickel metal will undergo this reaction. Here it will form ion and will come into the solution and lose 2 electron. These are the same 2 electron which were going there, okay, which were going there at the cathode. And so this nickel anode will finish after some time, will get depleted after some time. But the whole nickel will be electroplated on this iron spoon. So you can see 2 electron from here going towards the cathode. So the nickel is oxidized and it loses mass. So anode will disintegrate. When it finishes, but the coating is still not there, you will put one more nickel anode here till you get the final finishing. So now let's see in both the cases what is happening here. At anode this reaction is happening, at cathode this reaction is happening. The full iron spoon will be coated with nickel metal. So you have seen in the diagram, or you have seen in the video, that how electroplating with nickel was done. So let's check the text from your book. So why iron spoon is electroplated? Because it gets rusted and it is coated with the metal as nickel, tin or zinc to prevent rusting. Setup you have already seen there. There was a battery, then there was a meter to check the current, then positive and negative terminal. So always remember that the spoon which is electroplated is always made as the cathode. The metal which is used for electroplating is made the anode. And suppose here articles to be plated is suppose spoon, which we have taken as the example in the video. Electrolyte must be the solution of the substance which has to be electroplated, or whose electroplating has to be done. So here nickel was taken to plate iron. So I will take the solution as nickel sulfate. Now here you can see small amount of dilute sulfuric acid is used as a electrolyte. So they have put electrolyte as nickel sulfate. A small amount of sulfuric acid was added and water was also added. So how many ions? Positive ion nickel and hydrogen. Now nickel 2 plus ions will gain 2 electrons and will deposit at cathode, Why it is so? Because we have hydrogen which is lower. You will say, ma'am, it is lower in the series, but the reason is of high concentration of nickel ion. Nickel ion has high concentration here. That is why nickel is given preference due to its high concentration. So nickel ions are discharged at the cathode as neutral nickel atoms by gain of electron. Okay, I have told you why. Now this is the reaction at anode. So reactions at cathode and reactions at anode are very important. You have to learn them. Now these two, again, no, these are not discharged. Sulfate ions and hydroxide ions both migrate to the anode, but neither are discharged. So they are known as spectator ions. And why is it so? Because of the nature of the electrode. Because we have active electrode. Nickel is an active electrode, and that is why they both don't get the chance. Instead, the nickel anode loses electron to give Ni2 plus ions. This is, I've already told you many a times while teaching, that articles to be plated is always kept at the cathode. Electrolyte must be a solution of the salt of the metal to be electroplated, and anode is made of a strip of metal to be plated. So three very important points which you always you will remember whenever you will be studying any electroplating.
Let's see what are the conditions of electroplating. How do we do electroplating? What are the requirements? So first condition is the articles to be electroplated is always placed at the cathode. ध्यान रखेंगे इसको, very important, that you have to place the article which has to be electroplated. Means the article, suppose if I want to take a iron spoon and I want to electroplate it, so I always have to make that iron spoon as cathode. If I take a coin, I will show you one demonstration also, that a coin is electroplated with a nickel. So that coin will always be made as cathode, and the metal which we want to put as electroplate, means जिसकी हमें layer चढ़ानी है उसके ऊपर दूसरे equipment के ऊपर, for that has to be made as anode. So remember this always, never interchange these two things, otherwise your reaction will be wrong, the question will be, answer will be wrong. So you have to remember that you have to make it as cathode. The metal is always deposited at the cathode by the gain of electron. If you remember, I gave you two mnemonics, red cat, that is reduction at cathode, or rig. What is rig? Reduction is gain of electron. This you have to. So reduction always happens at cathode, and what is reduction? Reduction is gain of electron. So cathode पे क्या होगा? Gain of electrons. The metal to be electroplated on the article is always made as anode. I have already explained this, and it has to be periodically replaced because as you know, anode will finish after some time. No? Anode जो corrode होता जाता है, anode खत्म होता जाता है. In the last experiment we have seen what has to be taken as cathode, what has to be taken as anode. But one very important thing which we use in electrolysis is electrolyte. What you have to do with the electrolyte? क्या electrolyte use करेंगे? कौन सा electrolyte use करेंगे? So always remember, electrolyte must contain ions of the metals which is to be plated on the article. Suppose I want to electroplate gold on anything, तो मुझे जो electrolyte लेना पड़ेगा वो किसका compound होना चाहिए? वो gold का होना. Okay, so if I want to electroplate anything with silver, so I should take a silver compound. And why it is so? Because when you start electrolysis, I told you that electrolyte dissociates, breaks down into ions. Now these ions of the metals, they migrate towards the cathode. अगर electrolyte में silver है ही नहीं तो वो move कैसे करेगा cathode पे ना? So very important thing, that you have to electroplate whatever article you have to electroplate, whatever salt you are taking, whatever metal you are taking, you have to take the salt. This we'll see one example when we'll see electroplating. A lower current for a longer time should be used. Faraday's law, if you remember, I have already explained this. The amount of current is directly proportional to the coating. If high amount of current, uneven coating हो जाएगी, एकदम से बहुत सारा metal एक place पे हो जाएगा, बाकी जगह छूट जाएगी. तो low current for a longer time will give a even coating. Thicker and uniform deposition will happen. Direct current, you have to use direct current. This is the most important thing, because alternating current, this already I have explained in the last lecture, but again I am revising that alternating current is not used because it changes the poles. कैथोड एनोड में कन्वर्ट होता है, एनोड कैथोड में कन्वर्ट होता रहता है अल्टरनेटिंग करंट में, तो पता चला एक बार डिपॉजिट होगा फिर दोबारा हट जाएगा, फिर दोबारा डिपॉजिट होगा, दैट विल नॉट हैपन बिकॉज इट चेंजेस द पोल. इन डायरेक्ट करंट, एज आई टोल्ड यू, व्हाट इज डायरेक्ट करंट? डायरेक्ट करंट मीन्स द फ्लो ऑफ इलेक्ट्रॉन्स आर इन ओनली वन डायरेक्शन. So once a cathode, always a cathode. So AC current causes discharge and ionization to alternate at the cathode, thus giving no effect of coating. So I hope this is clear that cathode pe. So first example is coming on our way, electroplating an article with silver. Now I have taken a brass spoon here. So first characteristic was that I have to make this brass spoon as cathode. Remember है ना, जिसको इलेक्ट्रोप्लेट करना था उसको कैथोड बनाना है, और जिससे करना है सिल्वर, सो आई हैव टू मेक silver as anode. Now first of all refining is done. Suppose I want to do electroplating of any object, I have to wash it and make it clean so that no layer of any impurity is there on it. So first step in electroplating will be cleaning it. When we have washed with hot and solution of caustic soda. And why we have taken caustic soda? What is caustic soda? You remember? It is NaOH, sodium hydroxide. And why caustic soda is preferred here? Because caustic soda actually dissolves all kind of grease, and thus it gives a very effective cleaning effect. So that is why we have used caustic soda here. And then we do it with dilute hydrochloric acid. So you have seen first they have done the cleaning with alkali, that is caustic soda, and then they have done the cleaning with acid. तो जो भी दोनों में इम्प्योरिटीज़ जो भी मिक्स हो जाती हैं, अगर बेसिक वाले में अल्कलाइन वाले में मिक्स हो जाती हैं जो इम्प्योरिटीज़, दैट विल मिक्स इन NaOH, एंड इफ हाइड्रोक्लोरिक एसिड वाले में जो एसिड में मिक्स हो जाती हैं वो मिक्स हो जाएंगे. तो मीन्स इट विल बी वेरी वेरी इफेक्टिवली, द ब्रास स्पून इज cleaned very nicely by using these two substances, and then it is washed with a detergent several times with distilled water. Why distilled water is used? Because it is the purest form of water, it has no residue, it has no salt on it. If you wash it with tap water may have dissolved impurities, so those impurities may be there on the spoon. The spoon is then dried and made the cathode. So just look at this setup. This is the spoon which we have taken, it is made as cathode, and the pure block of silver is taken as anode because we have to electroplate it. And as I told you that electrolytes should be the salt of the thing which you want to electroplate, that is silver. So the solution of sodium argentocyanide. Now argentocyanide means, okay, so let's start how I have taught you in the last this thing. That first is, so first we have to see that what is the electrolyte. We have taken sodium argentocyanide, or here we can take potassium argentocyanide also, both can work. And then we have to see that how ions are formed, if I break sodium argentocyanide, then it will dissociate into Na plus ion, silver ion, and I am going to get cyanide ion. Okay, so these are the anions and cations formed. Now here you can see that sodium and silver both are positive ions. So remember, they both will go to cathode, but who will be discharged? How you will come to know that who will be discharged? For this we have to check electrochemical series of metals. Let's see the position of sodium. Sodium is here on the top and silver is below sodium, बहुत ज़्यादा नीचे है ना. तो पहले कौन डिस्चार्ज होगा? ये वाला, क्योंकि the element which is down in the series get discharged first. उसको क्या बोलते हैं हम? Preferential discharge. So silver will be discharged at cathode, और हमें कैथोड पे सिल्वर ही तो चाहिए ना. सिल्वर की प्लेटिंग कर रहे हैं तो सिल्वर चाहिए. तो ये इस तरीके से both ions of sodium and silver will be formed, but preference will be given to silver. Okay, one more thing, as I told you, it is a solution of sodium argentocyanide. So one more cation will be formed, that is H plus, by the breaking of water, and then again you can see hydrogen is here. So then also the preference will be given to silver. So how many ions? How many positive ions here? Sodium, silver and hydrogen. But who will be given preference? So silver will be given preference because it is lowest in the electrochemical series.
So we have seen that the silver ion gain electrons and become atoms of silver, which deposit on the spoon as a firm coating. Thus, silver coating is done. Now, this thickness of the coating will depend upon the duration of the current pass. As long as you pass the current, the coating will be thicker. In the process, the anode dissolves, and you know the anode is dissolving, and it is the ions are deposited on the cathode as atoms. The electrolyte solution maintains the same concentration. Now, the solution has the same number of silver ions, and this happens till the anode is intact. As anode finishes, then the electrolyte solution fades. So, if the solution is colored, the intensity of the color remains the same because the ions are provided by the anode. The spoon is taken out of the bath and repeatedly washed several times with water, dried and polished. So, this is the last step which is happening. That if silver nitrate solution is used directly, suppose we don't use double cyanide of sodium and silver, if I am just using silver nitrate, then what will happen? The silver will be deposited very fast and smooth and uniform coating will not happen. So, we cannot use silver nitrate here because it will not give very smooth and uniform coating. Okay, so these are the things which you have to remember. First of all is what is the electrolyte used in this reaction. So, electrolyte is sodium argentocyanide. Formula is NaAgCN whole choice. Potassium can also be used in place of sodium here. So, it will be potassium argentocyanide. How it is produced? This is known as double cyanide. And how it is produced? It is produced by adding silver nitrate to sodium cyanide, and when we will get the silver cyanide again we add this silver cyanide to sodium cyanide, and then we get this double cyanide as sodium argentocyanide, which you have to remember. Dissociation, I have already told you that these are the three cations which are formed, but this will be discharged, and here no anion will be discharged due to the nature of the electrode, because you have taken active electrode as silver. So, this is the reaction at cathode, very important to learn. Reaction at anode, very important to learn. So, these two will not be discharged because of the active, due to the nature of the anode, because it is active electrode. So, it will not let anyone discharge, rather it will disintegrate and form silver ions. Now, we will see electro-refining of metals. So, this is the next application of electrolysis, where metals are refined through electricity. So, how does this refining is done? Electrolytic refining is a process by which metals containing impurities are purified electrolytically to give a pure metal. So, impure metal is converted into pure metal. So, let us see one example, refining of copper. So, let us see how copper is purified. You can see the setup on the screen. We have taken anode as impure. I already told you that you have to electroplate anything, you have to make cathode. So, suppose I have taken pure copper here, and then I want that pure copper cathode, it should collect more copper on it from the impure coppers, because we are making this impure copper as pure copper. So, we will make it as anode, and pure copper, very thin strip we can take as cathode. Later on this strip will gain mass, because this impure copper, from this impure copper, pure copper will go and deposit here. What is the electrolyte used? Acidified copper sulfate solution. Acidified, why acidified? Because to enhance the conductivity, we add little acid. So, we will take impure copper rod as anode and a thin sheet of pure copper as cathode. Cell will be added same way how we have made them earlier, and we have taken the electrolyte. As soon as you pass the electricity, something happens, and later on you will see that what will happen, this electrolyte will contain some ions here. Now, what are these ions? These ions are copper and sulfate ions. But what is happening? Similarly, that these copper ions will go here and deposit on the cathode, but they will not finish. They will not finish, because this anode, which is copper only, here Same thing as it was happening with nickel, this will happen. And here when the electric current is passed through the electrolyte, you can observe that the anode starts disintegrating and becoming small, and some dust particles they gather here down. This is the impurities which were there in this impure copper. And what is happening? This anode has copper metal, so this copper will break down as Cu2 plus ion will come into this electrolyte. So thus these ions get, and at cathode what is happening, these ions will get reduced to form copper and they deposit on this copper cathode. Sulfate ion will go to the anode, but they will not get discharged. Why? Because of active anode. It will not, this copper will not let sulfate ions charge on it, rather it will break down to form ions. So you see this anode is finishing and some impurities are there, which is known as anode mud. Okay, anode mud is the impurities from impure copper. Any metal can be purified with this method, that when you make it as anode, it will finish and the impurities will deposit down. Okay, so the setup which I have shown you was just a symbolic setup, because in refineries it is not only one slab which is purified, rather it is a collection of strips of, see, pure copper is here and then impure slabs are here. So these are all impure slabs, you can see here, and pure one is here. Later on when this thing finishes, you can see when this reaction finishes, you will see that opposite will happen. The pure copper will gain mass and become broader, and impure copper will become thinner. Electrolyte is copper sulfate with some dilute sulfuric acid. Cathode is the thin strip, and anode is a slab of impure copper, because in refineries huge amount of copper needs to be purified. And why do we need to purify copper? Because when you are using copper in making some wires or using it as some other processes, then you need them in pure form, not with impurities, because impurities will make their function less. That is why we need pure copper. These are the reactions which you have to learn at cathode. Always remember, cathode is reduction, red cat say. Anode is oxidation, anoxy. Reduction is rig, means gain of electron. So you will always show gain of electron at cathode. So I am giving you these mnemonics so that you remember always, and you never write the wrong reactions at cathode and anode. Oxidation, it is oil, that means loss of electron. So here you will show copper as losing electrons and forming ions. So this way, this is the definition of anode mud. Some impurities get dissolved in the acid, while others, namely silver and gold, which are insoluble, gets collected near the anode and are recovered later on. Zinc, lead, mercury, silver, copper are refined by electrolysis.